So we've been talking about data analysis, but it's also important to be able to communicate your findings and what you have in your data to a larger audience. That brings us into a conversation about data visualization. And I did a deep dive into data visualization last summer, read everything I could find on it, looked at thousands of examples, and it really just boiled down to some basic stuff. So, one, just don't do stupid stuff. There are some things that we know that make for better data visualization, worse data visualization. Don't do the worst stuff. Keep the point front and center. Keep some basic principles of graphic design in mind. And then oftentimes folks who are big on data visualization will push us to learn Python or R, but there's actually quite a bit of stuff you can do with Excel or with even SPSS as a more user-friendly statistical package that you might have access to. And so I tried to boil down some of this advice that comes from data visualization gurus. But I think the conversation really starts with thinking about what you're trying to communicate and who you're trying to communicate it to. So I would say always begin by defining your audience, right? Figure out who is going to be consuming this information, right? How much experience do they have consuming visual data? How is that graph going to be published? And you may make different design decisions if you are publishing to the web versus publishing to print. We'll talk about font as an example of that later on. You also might want to have a conversation with yourself about what's the context in which this is going to be presented. Is it going to be a graph within a larger article where people can read, 50 pages of information about that graphic, and it will be supporting that text, or is the graphic going to be sort of standing on its own? And depending upon how you answer that is going to determine a lot of how you approach that particular data visualization task. You should always have the message of what you're trying to communicate front and center. What's the story you're trying to tell? If you can't answer that for yourself, you have a lot more work you need to do before you start having a conversation about data visualization. You should know what it is you need people to take away and understand about the data you're trying to present. You should have a conversation with yourself about the nature of your data, right? Are you looking at categorical variables? Are you looking at continuous variables or interval ratio variables? Are you looking at one or more? Are you trying to show a pattern or just describing sort of how things are distributed based on the type of data you have and how that data is organized and coded? You're going to make different design decisions. And then once you understand all of that, then you can select the appropriate chart or graph or map or combination thereof. But until you've worked out all those other pieces, everything else is just sort of a side conversation or a conversation for the future. When we're working with categorical variables, there are a lot of different possible options. I could talk about the pros and cons of each. I don't know that that's necessarily a useful way to spend anybody's time. I will just flag that bar charts and pie charts tend to be the most familiar to people, whereas tree maps, radar plots, and number lines tend to be maybe less familiar to people as ways of communicating data, but these are all communicating essentially the exact same set of data, how three different categorical variables are distributed. When we're thinking about interval ratio variables, our options are, the histogram or the box plot. Increasingly, folks are using stream plots, and increasingly less people are using stem and leaf plots. Stem and leaf plots were used in the olden days when we had to sort of do this by hand. Now that we have computers that generate most of our graphics, people tend to opt for different ways of communicating those patterns. Again, each of these four different visualization approaches are using the same basic data and communicating that there's not a lot of interesting information there, I guess. I would caution folks when thinking about selecting a graph or selecting a data visualization strategy, that there's oftentimes a trade-off between the amount of information that we provide people, the detail that we give them, and the readability of the graphic. Right? And we want to be able to provide people with as much information as possible, but we don't want it to be overwhelming and messy. And there's some graphic design strategies that we'll talk about that can help us to maybe deal with some of that. And so we'll talk about hierarchical design principles where we think about where does your eye target first, and then where does it go second? And if you put the important piece of information first, and then the second piece is sort of where your eye goes next for maybe some follow-up detail or maybe for some information about how that data was coded, then it can be less cluttered to the eye than if you don't pay attention to hierarchical design. White space is really valuable if you're, particularly when you have a lot of information, if you're trying to make it not feel cluttered and chaotic. Give yourself the space to do that without it sort of becoming overwhelming. White space kind of calms things down a little bit. And then lastly, do not underestimate the value of clear and readable fonts. If you are in a print setting, you will probably want to use a serif font. Our eye can pick up those little, corners and circles and edges on serif fonts in a way on print that makes it much more readable. If you're in a digital environment, there's fewer pixels that are being transmitted to our eyes, I guess. And as a result, those sort of little edges and sort of curves and quirks of serif fonts don't always come through quite as well. And our eyes actually read sans serif fonts better. And so if you're not 100% familiar with the difference, the font in the green bar is a serif font. There's all these little decorative elements in it, whereas the font in the white is a sans serif font, where it's just lines without the decorations. A second trade-off I would maybe encourage you to think about is whether or not you are presenting your information to be as clear as it possibly can be in terms of the data, or if you're presenting the data to be easily interpretable by your audience. And you'd think that those would be the same, but they're not always. And so I'll flag this little visualization where we have two ways of communicating the exact same information. One is a pie chart, which pretty much everybody is familiar with. We all understand what pie charts do, and we understand how to extract information from them. The other visualization strategy is a line graph or a line plot, which aren't as familiar to people, right? They encounter line graphs in math, probably in elementary school, but as a data visualization strategy, this isn't as widespread. And yet, if I'm thinking about this from the perspective of communicating useful information, and I'm looking at those pie charts, and I just tracked sort of the orange slice, I can't really see much of a difference across those orange slices. And yet, if I look at the line graphs, I can see that the orange slice started out last. It sort of crashed and burned a little bit. It kind of rebounded a little bit, and then it gained. It's now in second place in that sort of fourth year. Similarly, I can look at the blue in the pie charts. I can't tell sort of how much things are changing. It nudges a little bit, but with the line graph, it's very obvious. It was sort of a distant second, then it surged to first place, then it fell back to a distant second, and then by the fourth year, it was in last place in terms of these three different categories. So I can pick out more information more easily from the line graph. That would be a data-centric way of visualizing data. But because line graphs aren't as familiar to people, your audience may not put in the extra like 10, 15, 30 seconds it takes to figure out how to read and interpret those graphs. And that's a frustrating thing from a data visualization perspective, that there are better ways to do things, but if your audience can't figure out what it is in a timely enough fashion, they're going to skip right over it and not really extract from it what is there to be extracted.